Hey there. Welcome to chapter 2.2, which is all about the cycles of matter. First on the list is the carbon cycle, right here. Plants use energy from the sun and convert carbon dioxide and water into energy and oxygen. As one organism becomes food for the next organism in the food chain, the carbon-containing materials are passed along. When organisms use the food energy, the carbon is converted back into carbon dioxide and is available for plants to use once again, and the cycle continues. Scientists use this model, called the carbon cycle, to show how carbon is used over and over and over again in ecosystems. Take a look how photosynthesis brings the sunlight in and the plants use it up. Animals then eat those plants containing carbon and breathe out carbon dioxide, which is then recycled back into the plants as they breathe and make more energy. You can see also as an animal dies, it releases carbon into the soil for again plants to reabsorb that. Some carbon even goes into the oceans, deep into the oceans, goes into the soil and is recycled as volcanic eruptions later on. Not all carbon in plants and animals is converted back into carbon dioxide immediately. When organisms in oceans and lakes die, their tissues often drift and form a thick layer of carbon-containing materials. These materials are then covered with sand and silt and buried deeper and deeper. After millions of years, under all that pressure from the ocean's weight, the carbon-containing materials are converted into coal, oil, and even natural gas. When people burn the coal, oil, and natural gas for fuel, like to fuel my car, the energy is released once again, and the carbon is converted into carbon dioxide. These processes contribute to the carbon cycle. Let's talk about the water cycle. The water cycle is the continuous movement of water through the environment. There are four main processes in the water cycle. Number one, evaporation. Evaporation is the process in which liquid water changes into gaseous water, aka water vapor. Water is always evaporating from streams, lakes, and ponds and puddles. Water is also evaporating from your skin when you sweat. Second step is transpiration. This is the process which water is taken through a plant's roots and evaporates from the plant's leaves, stems, and flowers. Third step, condensation. This is a process where water vapor cools down and changes back into a liquid form as tiny droplets of water. The droplets are so tiny, they remain hanging in the air as clouds. Finally, step 4. Once it's cooled down and the droplets get heavy enough, it rains, aka precipitation. The rain can fall as rain, sleet, snow, or hail, depending on the temperature in which it forms. If it's colder, it turns to ice or snow. If it's warmer, it turns to liquid. Take a look at this diagram that illustrates it here. A couple things to note. What is groundwater? Well, obvious enough, it's the water in the soil. The roots of the plants can grow down deep into the groundwater, and people often dig wells to reach this water. What is runoff? Well, runoff is the water that runs along the surface of the ground into lakes and rivers. Now we gotta talk about pollution in the environment. It's part of the cycle, believe it or not. Now, water and carbon constantly cycle through the ecosystem. Pollution is any substance that is added to the ecosystem or environment so fast that it cannot be broken down, stored, or converted to another form that is not harmful. Pollutants are substances that cause pollution. Now, pollutants move from one level to the next in a food web, but they're not broken down like food is. If an organism consumes a pollutant, most of it remains in its tissues, like plastic. Each animal in the food chain receives nearly all the pollutant that was consumed by the organism below it. For example, if a rabbit ate a piece of plastic and then a wolf ate the rabbit, the wolf now also accumulates that plastic, and it stacks up if the wolf eats one and then a bear eats the wolf after that. And now there's more and more plastic in the bear. The bear gets the worst of it. The buildup of these pollutants in organisms is called bioaccumulation. Now check out this example with the killer whale. It lives off the coast of BC and it's a top consumer, an apex predator. The pollutants in the water can enter the food chain at any level, but they often enter through an organism that are lower on the food chain. For example, a pollutant might be absorbed by phytoplankton, the bottom layer. Many orcas are now becoming ill due to bioaccumulation of pollutants. Check out this video that shows a new animal and adaptations where creatures can thrive in the Pacific garbage patches in the ocean.
Plastic. Sometimes these garbage debris fields are so concentrated that they get their own names, like the Great Pacific Garbage Patch. It turns out that an entire class of organisms lives their entire lives among the trash, and in great numbers. And these creatures look nothing like almost any other animal. Forget fins and tails and glittering scales. These jellyfish, snails, barnacles, hydrozoans, and nudibranchs belong to a class of their own, with fantastic and beautiful adaptations to their environment. These floating organisms live on the surface of the water and go wherever the wind and ocean currents take them. They come in dazzling shades of blue and purple, helping them blend into the surface of the water. And each has its own special trick for surviving their unique environment. An environment which is a thin sliver of water and air that's only about 1 meter in thickness. All of these organisms live right alongside the plastic, which means whenever we try to collect all that trash, we're also inadvertently sweeping away and killing hundreds or even thousands of unique organisms. So, what are we supposed to do? Is there a way to clean up the ocean without killing all of these incredible life forms? Or do we simply just leave all that trash? How important to the health of the overall ocean are these colorful floating creatures? And what other mysteries might they still hold?